There is a planet at the edge of our solar system that scientists, for decades, essentially agreed to ignore. Not because it was dangerous, not because it was hard to find, because it looked boring. A smooth, featureless, pale blue ball with nothing going on. And for 37 years, almost 4 full decades, we accepted that story. We moved on. We sent probes to Mars. We flew past Pluto. We pointed our best telescopes at galaxies billions of light years away. And that little blue nothing just sat there. Here's the thing about Uranus. It wasn't boring. It was lying. Before we get to the storms and the smell and the diamonds, yes, I said diamonds, let me tell you how this planet was even found, because the discovery itself tells you everything about what kind of planet this is. The year is 1781. A German-born musician living in Bath, England, a man named William Herschel, has built his own telescope in his backyard. Not a professional, not affiliated with any observatory, just a guy who is, frankly, obsessed. One night, he catches something that isn't quite behaving like a star. It moves. It has a slight disk. It doesn't twinkle the way a star should. He thinks it's a comet. It isn't. It is a planet. The first new planet discovered in recorded human history. Every world known before that moment, Mercury, Venus, Mars, Jupiter, Saturn, had been seen by ancient people with their naked eyes for thousands of years. Nobody discovered them. They just were. Uranus was the first one we had to go hunting for. And here's what I find poetic about that. From day one, this planet only gave up its secrets reluctantly. It let Herschel stare at it for months before he stopped calling it a comet. It wore a featureless face for Voyager. It kept its weather hidden for 37 years. Uranus doesn't volunteer information. You have to take it. All right, let's talk about the thing that broke this planet. Every planet in the solar system spins. Most of them spin roughly upright, like tops on a table. Earth leans a modest 23 degrees, which is why we have seasons. Saturn leans about 27. Even the most tilted, normal planets are still fundamentally upright. Uranus is tilted 98 degrees. Not leaning, not tilted, fallen over, rolling on its side like a bowling ball down a lane. Its poles don't point up and down, they point sideways, straight at the sun and straight away from it. Whatever hit this planet, and something enormous did, almost certainly another world-sized object early in the solar system's history, it didn't just nudge it, it put it completely on the ground, and Uranus never got back up. Now think about what that actually means if you were standing there. Uranus takes 84 Earth years to complete one orbit. Lying sideways, one pole spends 21 years aimed almost directly at the sun. 21 years of uninterrupted daylight. No sunrises, no sunsets. Just a dim, distant sun tracing slow circles above you, never dipping below the horizon, for 2 full decades. And the opposite pole? 21 years of complete, total darkness. Now, temperature. Uranus is the coldest planet in the solar system. And I want to stop right there, because that sentence hides something wild inside it. Uranus is not the farthest planet from the sun. Neptune is farther. And yet, Neptune is warmer. Uranus holds the record for the lowest measured atmospheric temperature in the entire solar system, negative 371 degrees Fahrenheit. Antarctica, the coldest place a human being has ever survived, would feel practically mild on Uranus. Not slightly warmer, not a little more bearable, genuinely, comparably warm. So why is the closer planet colder? The honest answer is, scientists are still working it out. But the leading theory traces back to that ancient collision. The same catastrophic impact that knocked Uranus sideways may have also fractured or disrupted its core in a way that shut off its internal heat engine. Neptune still radiates more energy than it receives from the Sun. It glows from the inside. Uranus barely does. It's a planet that may have had its internal furnace switched off 4 billion years ago and has been slowly, patiently, silently freezing ever since. Here's the part that makes astrophysicists chuckle and everyone else grimace. In 2018, a team of astronomers using a telescope in Hawaii analyzed the composition of Uranus's upper cloud layer. After decades of not knowing what was up there, they finally cracked it. The clouds are rich in hydrogen sulfide. That is the chemical compound responsible for the smell of rotten eggs. The upper atmosphere of Uranus, the first thing that would hit your face if you somehow arrived there, smells overwhelmingly of rot. The scientist who led the discovery was remarkably direct about it. He noted that a hypothetical human falling through those clouds would encounter extremely unpleasant and rather pungent conditions, but that the freezing temperatures and the lack of breathable oxygen would kill them so quickly the smell would barely register as a final indignity. It was framed as reassuring. It was not reassuring. Uranus is a planet that will kill you in at least 3 different ways simultaneously, and it throws in a rotten egg smell just to make sure you feel disrespected on the way out. For almost 40 years, our most detailed portrait of Uranus came from a single source: Voyager 2's flyby on January 24, 1986. The spacecraft swept within about 50,000 miles of the cloud tops, snapped its photos, and kept moving. And those photos showed almost nothing. A smooth, pale, featureless sphere. Then the James Webb Space Telescope looked at Uranus, and the blue marble completely disappeared. Here's the critical difference. Voyager, like your eyes, used visible light. Webb operates primarily in infrared heat light, the kind that reveals what things are doing, not just what they look like. And in infrared, Uranus lit up like a completely different world. Gone was the blank face. In its place, a massive, bright polar cap sitting over the North Pole, a vast hood of haze that was essentially invisible to every instrument that had ever looked before. At the center of that cap, a churning polar vortex, a storm system anchored over the pole, rotating, warmer than the surrounding air, actively alive. Scattered around the cap's edge, discrete storm clouds, the weather we'd been told this planet was too dull to have. Uranus had been doing this the whole time, for all 37 years. Every time we looked and saw nothing, it was because we were looking wrong. The moment we looked in the right kind of light, the disguise dissolved instantly. And the timing of Webb's observations turns out to be extraordinary. Uranus is approaching its northern solstice, the moment in 2028 when its North Pole points most directly at the Sun. As it does, scientists are watching the polar cap grow brighter, change shape, and transform in real time. Nobody has ever watched a Uranian season change live before. We're watching it now. Then Webb went hunting for rings. Most people don't know Uranus has rings. They're nothing like Saturn's. They're dark, thin, and nearly invisible. In one image, Webb captured 11 of Uranus's 13 known rings, including the faint, ghostly Zeta ring that we had barely even confirmed existed. But here is the visual that stays with you. Because Uranus is tipped on its side, its rings don't circle its equator like a belt. They stand up vertically, like a giant bullseye painted around the planet. A target, rolling through the dark. That image, that bullseye rolling through space, is one of the most quietly unsettling things astronomy has produced in years. It's not frightening on its face, but when you understand what it means, that something out there hit a planet hard enough to lay it permanently on its side, and those rings are the fingerprints it left behind, it stops feeling like a pretty picture. Uranus currently has 29 known moons, and that number only went up recently. In early 2025, a team studying Webb imagery spotted a tiny new moon, roughly 6 miles across, tucked in close to the ring system. So small that Voyager 2 flew right past it and never noticed. A moon that had been hiding in plain sight for the entire history of the space age. The moons of Uranus are named differently from almost everything else in the solar system. While most planetary moons get names from mythology, Greek gods, Roman gods, various ancient pantheons, the moons of Uranus are named after characters from Shakespeare and Alexander Pope. Titania, Oberon, Miranda, Ariel, Puck, Umbriel. A frozen royal court of literary ghosts orbiting a sideways king in the dark. And one of them, Miranda, hides something genuinely startling on its surface. Miranda is tiny, less than 300 miles across. From a distance, it looks like a scuffed, battered snowball. But carved into its surface is a structure called Verona Rupes, a cliff that drops somewhere between 12 and 20 kilometers straight down. The tallest known cliff anywhere in the solar system. For context, that is more than twice the height of Mount Everest, as a single vertical wall of ice. Now here's the part that will sit in your brain. Miranda's gravity is so feeble that if you stepped off the edge of that cliff, you wouldn't plummet. You'd fall slowly, drifting, tumbling, in total silence for somewhere around 10 full minutes before you reach the bottom. 10 minutes of falling. No sound, no air, no rushing wind, just silence, darkness, and the slow, patient drop. It is, by a wide margin, the most extreme freefall available anywhere in the solar system. Let's go deeper. Because everything I've described so far, the tilt, the cold, the smell, the storms, that's all surface behavior. The real strangeness is inside. Uranus has no solid surface. If you flew a spacecraft into it, you wouldn't crash, you'd sink. The atmosphere would just get denser, the pressure climbing with every mile until the ship was crushed flat. And you'd keep falling into something that isn't quite gas and isn't quite liquid, a phase of matter that doesn't have a common name in everyday language. There is no ground, no floor. Just an endlessly thickening ocean of pressure that swallows everything and gives nothing back. And that ocean, the bulk of Uranus, thousands of miles deep, is a vast, superheated fluid, a churning mixture of water, ammonia, and methane compressed under pressures we can barely simulate on Earth, electrically charged, with no surface and no shore. Hotter than the surface of some smaller stars, locked under pressure so extreme it can never escape upward. An ocean that wraps the entire core of the planet, spanning depths our deepest probes have never come close to reaching. You couldn't drown in it. You'd be crushed and cooked long before the concept of drowning became relevant. And then there's the rain. Deep inside Uranus, in the right combination of temperature and pressure, something extraordinary happens. The methane in that interior ocean is loaded with carbon atoms, and when you squeeze carbon hard enough under the right conditions, it does something remarkable. It crystallizes. It becomes a diamond. Those diamonds, denser than the fluid surrounding them, sink. They fall through thousands of miles of superheated ocean, slowly, silently, toward the core. Researchers have actually reproduced this in a laboratory setting, firing intense laser pulses at the right compounds, watching diamond formation happen in the shock wave. It works exactly as the models predict. So somewhere inside the coldest, most hostile, most forgotten planet in our solar system, right now, in this moment, there is a permanent, silent storm of diamonds falling through the dark. No light has ever touched it. No eye will ever see it. The most beautiful meteorological event in the solar system, happening continuously in the most inhospitable place we know. One final detail, and it might be the strangest of all. Every planet with a liquid interior generates a magnetic field. Earth's is clean. It runs pole to pole, roughly aligned with our spin axis, like a bar magnet sitting neatly through the center of the planet. Uranus's magnetic field is tilted 60 degrees away from its spin axis. And it's not even centered, it's offset, shoved to one side of the planet, as if something reached in and wrenched it loose from its anchor point. The result is a magnetic field that wobbles, lurches, and spirals as the planet rolls. There is no clean north and south. The field tumbles through space with no stable geometry. When Voyager flew through it in 1986, the data was so bizarre that scientists spent years just arguing about what they were looking at. A planet's magnetic field is supposed to be the deep order at its core, the bedrock of stability beneath all the chaos of weather and atmosphere. On Uranus, even that is scrambled. Whatever struck this planet 4 billion years ago didn't just tip it sideways. It seems to have disordered it from the inside out. And 4 billion years later, through the formation of its rings, the growth of its moons, 37 years of invisible storms, Uranus still hasn't found its balance. Here's the question worth sitting with. When we survey other star systems and catalog the planets we find, a pattern emerges. The most common type of planet in the observable galaxy, by a significant margin, is something roughly the size of Uranus or Neptune. Not gas giants like Jupiter, not rocky worlds like Earth. In between, cold, hazy, dense. Which means the planet we spent 40 years calling boring, the one we joked about because of its name, the one we visited once and then forgot, may be the most ordinary type of planet in the universe. Earth might be the rare exception. Uranus might be closer to the standard. We looked at the most common kind of world in the galaxy and decided it was the one not worth visiting. We have sent exactly one spacecraft to Uranus. It visited in 1986 and never looked back. A dedicated orbiter mission, a probe that would fall directly into that rotten, frozen, diamond-filled atmosphere, has been ranked as the top priority for the next generation of planetary science. If it's approved, funded, built, and launched, it would still take over a decade just to arrive. The engineers who dream up that mission today may be retired before it gets there. That's the price of visiting a world this far away and this long ignored. But here's what I keep coming back to. For 37 years, we looked at a pale blue marble and called it dull. And for 37 years, underneath that calm face, a planet was doing all of this. Rolling through permanent twilight, raining diamonds in the dark, running storms we couldn't see, breaking the rules of planetary magnetism, hiding moons from our best spacecraft. The universe didn't hide this in some distant corner. It left it right here, in our own backyard, wearing a pleasant blue disguise. And the only reason we finally found out the truth is that we looked closer. Makes you wonder what else we've written off too quickly. Thanks for watching. I'll see you in the next one.